Hey guys, I'm just going to pop on here real quick just to kind of give you guys a heads up. Anybody that's watching or hasn't really paid much attention here lately, we just had a pretty decent earthquake here in California. It was a 7.1. I actually was making a video talking about some of this, and so I'm just going to do this one instead. I'll show you what I mean here in just a second. I had put together some captures talking about some solar winds and stuff, and I'll go into that here in just a second. But this is going to be a fairly short video. I'm going to keep it that way because I think this right here just says pretty much everything. This was a 7.1. It was really shallow. Again, it says it earlier. It was like zero point 0.9 kilometers deep. I don't know why they changed that. Maybe it was a typo of some sort. But again, it's saying it was 17 kilometers deep, which, guys, that's really shallow. Okay. So any kind of movement that close to the surface, I mean, especially like in the 7.1 area, wow. Okay. I mean, that's shaking. I mean, it'd be shaking pretty good. I was watching some of the live news reports and stuff from Texas News Studio, and he had the local news on there, and the emergency management people were talking about this, and they were saying that if you were standing like on your front porch or even in your house somewhere, and this quake happened, by the end of the quake, you would be standing without moving 18 feet away. Okay, that's how much it was shaking. Now, you put that however you want to put it, but these were shallow quakes. These weren't real deep. Okay. Now, we all thought the 6.4 from the other day was the main event here, right? Well, obviously now they're calling that a foreshock. Okay, because it happened before this main one. And we're assuming right now that this is the main one. We don't know for sure. There's no way to know for sure. Okay. Now, it's probably educated guess to say, hey, yes, this is probably the bigger one. This is probably where it's going to stop as far as going up in intensity. Now, I'm not saying it can't, but once this pressure is released a little bit here, and I'm going to talk about that a little bit too. We had the one up in Canada in the Cascadian subduction zone. Okay, I talked about that before. And it was like a 6 something. And then the next one we had, the bigger ones, was the 6.4 down here in California. Now, it's basically the same area of the globe. Yes, there was many miles between those, but that pressure probably transferred that direction, and that's why we got that one. But what was really weird about it to me is that it didn't drop in intensity. Typically, those events are related, once those once the pressure of all that gets released some, the intensity of the ones that happen after that typically go down. Okay? But this didn't do that. Now, this even proves it even more that even after the 6.4 in California, now we have a 7.1. Okay, why are these, popping off like this? Okay, well, you guys probably know where I'm getting ready to go with this. Obviously, we're going to talk about space stuff that causes this stuff. Solar winds mainly, okay? Now, we just had this event we've been talking about, and it was about, but that was directional pressure, okay, that did not come from the sun. Now, I'm going to show you guys some stuff here that I'm going to show you that the solar winds and stuff we've been experiencing today and yesterday some probably did come from the sun, at least some of them, the majority of them. All right, now what do I mean by that? Well, let me just take you out of here, and we will go. So I'll show you the captures I had taken, and then we'll talk about them here. Okay. Now, this capture was taken from SDO. It's the satellite sits out in front of Earth. It's as if we walked outside and looked up at the sun. This is what we would see. Okay, if we could see in this filter with our eyeballs. But this was taken on the 1st. This capture was taken on the 1st, okay? Now, this coronal hole right here, okay, anytime there's a coronal hole that's Earth-facing, our solar winds go up. Okay, that's just what happens, especially when we connect to it magnetically, all right? Now, if you read what I wrote in there, okay, increased solar winds expected by July 3rd or 4th. Yes, that came to fruition around the 4th, and we were still getting some from this coronal hole. That's not no little chump-sized coronal hole, okay? It's not huge, but it's not small. All right, now, that doesn't have anything really to do with its intensity of the solar wind, but it is larger in size, and it's in what we call the Earth strike zone, okay? That means it's rotated in front. It was facing Earth, and that became right in the spot it needed to be for us to be affected the most by this thing, okay? Now, again, this was taken on the 1st, so given that, you have to understand that it takes these winds some time to get here because they travel at a speed, okay? They have mass. They're traveling, okay? It isn't something like a solar flare that's basically just light and radiation that gets shot out really fast. The solar flare will hit the Earth in like 8 minutes if it's Earth facing, okay? Because it's moving so fast. These solar winds don't move that fast, but they're still moving extremely fast. And I'll explain a little bit more here in a minute. But this right here is what's going on right now. Okay, this coronal hole, in my opinion, has something to do with what happens right here. Okay, the solar winds increase. We see all this different action going on our magnetopause, plus the stuff that happened that didn't come from the sun. We were talking about that. Okay, all that stuff hitting us over and 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 over again. I mean, I have a hard time believing that didn't have something to do with what's going on. Okay, so, and again, keep in mind the one up in Canada, it kind of moved down, went to California, was like a 6.4, now this 7.1. So what I'm saying, guys, is this. Okay, please pay attention to this, please. All right, I took this capture today, and like I said, I was already making a video on this when this earthquake happened. That's what's real strange to me in my mind. I was actually going to kind of just go out and give everybody a heads up, and then this happened. So, but this is another heads up. All right, now this, I just took this today. There's another coronal hole. The one I just showed you is now over here. Okay, this is the one that's now facing Earth. It's in Earth strike zone again. I'm pretty sure we'll connect to it and we'll get some, some decent size, and I'm going to show you what I'm talking about. Some really pretty good sized solar winds from it. All right, and we can expect that by the 8th or the 9th. Okay, because these things have speed, and I'll show you what I'm talking about. So, here's the predictive model, okay, that they show us over at the space weather site. Okay, the spiral graphs, this kind of explains, this right here is the Earth. I'm sorry, let me do this real quick. This is the Earth, that's the sun. Okay, the satellite's out here right in front of the Earth. Now you can see right here where that increased pressure is. That's already hit the Earth and passed out, but that would be on the 10th. Okay, so what I'm saying is kind of ignore the spiral graphs off to the left right now. I want to concentrate right here. Okay, this is a predictive and a historic model. It lets us see what happened the day before up to the day of, and then it tries to predict what the conditions are going to be for like 6 or 7 days ahead of us. Okay, now the only way they can really predict stuff like that, there's a lot to it, I guess, but the main thing that they can look at is existing coronal holes that they think are going to hold together until they become into our strike zone. Okay, now remember what I said, I put that on the picture back there on the 8th and 9th. This is the 8th right here. Okay, the top green line is the density, plasma density. Okay, this bottom green line is the actual solar wind speed. Okay, at the Earth position. The red lines is where stereo A is, and then the blue line is where stereo B is, which we don't get any data, or we don't get to see the data from stereo B. It had some malfunctions. It said back a few years ago, but I think it was because we were catching so many captures of stuff they didn't want us to see that they blamed it on something technical, and they just don't let us have that data anymore. But you know what I think is kind of funny? They still plot this thing. Okay, they know where this thing's at. So why are they doing? I don't understand why they're doing that if it doesn't work. So anyway, I wanted to put that out there. Now, back to the solar winds. Okay, the solar winds are here, like I said. So when the solar winds go up, the plasma density should go down, and vice versa. Okay, so if the solar winds are going down, the plasma usually goes up. Well, that's what happens in this model right here. Okay, but I want to point something out. Okay, you take a straight line and you draw it on the 8th down through here, right? If you kind of follow that for about 6 hours until this peaks, until this peaks up here and starts going down, we're getting increased solar winds along with increased plasma density. Okay? So in other words, right here they're throwing say it would be like somebody throwing a golf ball at you at 80 miles an hour would be right here. Okay, well 6 hours later it would be somebody throwing a softball at you at 80 miles an hour. Okay, so that's what I'm trying to say, is that the solar wind's going to speed up the density. In other words, it's going to be heavier and have more mass. I don't want to call it heavy. Sorry about that. But it's going to have more mass. So it's going to affect our magnetosphere and our magnetopause way worse than it would have if that hadn't have happened. Okay, increased solar winds are going to do that anyway. Increased density, plasma density, will do that anyway. But you add increased of both of those, then we're talking about some serious stuff, okay? Talking about some pretty good disruptions. I'm not saying we're going to have some big, huge event or anything like that. All I'm saying is we have to pay attention, because these earthquakes are now popping and we're not even to this intensity of anything yet. Okay? Yes, we're elevated some, and there's a lot more factors, guys, that go into trying to say, hey, this earthquake's going to happen here, here, and here, and all those kinds of things. All I'm saying is this is something that, one of the things that we do look for, okay? Increased solar winds when we're talking about earthquakes, especially if we're going to add in increased plasma density at the same time, because it'll affect us magnetically, which in turn affects earthquakes, guys. It just does. You know, mainstream's starting to tie into that now too. They're actually starting to talk about that. They used to just totally discount it. They don't now, thanks to people like, you know, Dutch Sense and Scott and Bennett Suspicious Observer over there and BP Earthwatch and many, many, many others. Okay, I think Laura Wells Research News and Astronomy Channel, she does a really good job, and I think she posted a video here. I think it was only like a minute long, but I think she was like listing the earthquakes and the days of when it happened and all those kinds of things. And she'll probably come back with a follow-up video. But please go over and check out her channel. Throw her a sub. She deserves it, okay? I mean, she does some really good work over there. And again, you know, always pay attention to Scott and what he's doing, because he's been around this game for a very long time. So you got to pay attention when he says stuff. I know that when he puts out like a watch kind of sorta, or warns people of certain things that could possibly happen, that he doesn't do that unless he has information to back what he's saying. In other words, he's not just going to come out there, throw it out there just to get somebody to watch his video or something crazy and stupid like that. Okay, he's not sensationalizing. Okay, what I'm saying is he doesn't want it to become a thing where people start thinking that people cry wolf, which is what's happening with a lot of channels. Okay, a lot of researchers and a lot of people that aren't doing their due diligence and trying to, give the best information, or at least saying, hey, this could happen. They're just losing some stuff. We don't want to get to the point where we warn somebody and they don't pay attention because we warned a week before and nothing happened. Okay? It's very similar to like the severe weather warnings we get. Most people, and I've talked about this before, most people will say, hey, a tornado warning, what happens? Everybody goes straight to the window. Well, if that tornado was right out their door and they didn't know it, they wouldn't be standing there talking to you anymore. Because they were warned 5 times the week before and no tornado ever came about. That's what I'm trying to say. It's very much like crying wolf. Okay? So that's why I only pay attention to a certain few when it comes to somebody giving somebody a warning. And Scott's at the top of the list for me. Dutch Sense is there. All these guys. Suspicious Observer, BP Earth Watch. And again, Laura does some reporting on this too. She does a lot of other stuff also. But go check out her channel. But guys, this is something we have to pay attention to. Okay, this is in our future right here. Is what I'm trying to tell you. Okay, today's the 5th or the 6th. And it's technically for me, it's here. Yeah, it is the 6th now. Okay, it's Saturday. Now in 2 days, we should start to see the effects of this other coronal hole. Are we going to see more earthquakes? I would probably say yes. Are we going to see them right where we're seeing them now? That I couldn't tell you. Okay? But all I can say is our chances for a larger earthquake globally is going to be raised. Okay? Whether it comes to fruition, I'm not sure. All I'm saying is that judging by this, engaging by this, we need to pay attention. Just have heightened alert, okay? Don't be fearful, but just have heightened alert. Try to do what you're supposed to, especially if you live in these high earthquake areas. And again, so anyway, like I said, it's not normal for the solar wind to go up, okay, at the same time as the density's going up. And again, we're only going to get roughly 6, 7, I guess maybe 10 hours of that increase of both of them at the same time. And then according to this model, it starts coming back down on the density, but the solar wind speed stays up. Okay? Which is kind of what it's supposed to do anyway. But, okay, so what we're going to do, see this right here? That says 550, okay? So we're just going to call the solar wind speed 500, okay? I'm going to show you guys how to convert some of this stuff real quick. I'll leave a link to this because I really want you guys to be able to do this for yourself. So what I'll do is I'll go to my converter. Alright. It is called, I forget what it's called, Unit Juggler. You can enter any unit and transfer it to any other unit. Okay? It helps you out here is what I'm saying. So, see, we had a solar wind speed of 500. And what that 500 is telling you is kilometers per second. That's how fast it's moving. 500 kilometers per second. So if I enter that in right here, and most of us go by miles per hour in our minds because we drive a lot, all those kinds of things. So we want to know things in miles per hour. It helps us understand. Okay? So if you take kilometers per second, convert it over to miles per hour at 500 miles per hour, that is going to leave you with 1,111,000 miles per hour. We're just going to call it 1,119,000 miles per hour, I guess. You just want to say that. But that kind of puts it in perspective, doesn't it, guys? That's how fast that wind's moving. If it wasn't for our atmosphere, oh man. That's why we get, concerned with our magnetopause, and our magnetosphere is having issues. It's getting weaker. So it's not going to take as much to damage that. It's not going to take as much for that energy to make it through our shields and actually get to us here on the surface. That's why we talk about this. Okay, so anyway, we'll just call it 1 million miles per hour. All right, just for whatever reason. The sun is typically, we like to say that it's 93 million miles away. Now, I know that some people don't think that that's true. I do. I do think that that's how far the sun's out there. I respect those that don't. I really do. I just haven't been shown, enough to back off of that yet. I don't think I don't know if I ever will be, but I do think the sun's that far away from us. So, anyway, this coronal hole moving at 1 million miles an hour, if it's 93 million miles away, what does that mean? Well, it's about 4 days, right? A little over 4 days before it reaches us. I took this capture on, let's see here, I gotta go back to it, sorry guys. Let's go here. I took this capture here. I took this earlier today. Okay, so you take today and you add 4 days to it. There you have it. That's when we'll see the effects of this. Alright? This is, we need to pay attention to this is what I'm saying, guys. Okay? Don't just discount this because we have to pay attention. So what I'm going to do, okay, let's just do this. Guys, I think I'm probably going to go ahead and end this video here just because of the situation. I have a lot more to talk about. I'll just make another video and we'll put that out tomorrow or the next day. I'm going to be talking about UV, UVC especially. I'll be talking about that again. I did a video on it already, but I think that I need to revisit that and do a little bit more of explaining. Okay, but just to show you what our magnetopause has been doing. Okay, look at this. Obviously, guys, that's not what it's supposed to look like. Okay, now like I said, I do think this energy right now is coming from the sun. That's why we got increased winds. So let's go over to space weather, find out what the kilometers per second is for your wind, and then convert it, and you'll know how fast it's moving, and then you can calculate a rough time frame of when it's actually going to affect us here on the surface. That's the process that I use. Okay, and a lot of others do the same. But just keep in mind that plasma density, when it goes up, the solar wind speed goes down, and then when the wind speed goes up, the density is supposed to go down. And again, it doesn't happen like that all the time, but the majority of the time it does. So when we see them both going up at the same time, like we see here, okay, that really causes us to look, because it is what it is there. But so with that being said, guys, I'm going to go ahead and end this video. God bless. Yeshua saves, and you can drink this Kool-Aid.